I'm thrilled to introduce Dr. Pierre LaRochelle. He serves as our department head and professor in the Leslie A. Rose Department of Mechanical Engineering at South Dakota Mines. His research focuses on kinematic for the design of complex robotic mechanical systems and enabling creativity and innovation in design. He's the director of our Robotics and Computational Kinematic Innovation, or much easier to say, ROCKIN laboratory. He has over 100 publications, holds 3 U.S. patents, and serves as a consultant on robotics, automation, and machine design, creativity and innovation, and computer-aided design. He currently serves as American Society of Mechanical Engineers, or ASME, as Senior Vice President for Public Affairs and Outreach. So we are very honored to have you join us here today. And with that, I turn it over to you, Pierre.
Hello, everybody, and thank you so much for that very kind introduction, Shelley. I'm very happy to have this opportunity to share some updates about the Stensaas Labs in our department. I'm going to share some slides here. So give me a second to get this going. All right, so the Stensaas Lab edition of the update. So we'll talk about the Stensaas Labs. So if you're an ME alum, I'm talking about the labs that are in the central portion of the second floor of the CM building, right? The CM building having been our home since our department's founding, right? Since 1951, okay? So what I'm going to do now is I'm going to take you through all the different spaces that are involved in the Stensaas Lab. And we'll start out with the zoo. So the zoo, and we have some fun names for our spaces, right? And these names come from the students, faculty, sometimes staff, right? So the zoo is that main central portion of the Stensaas Labs on the second floor in the CM building. And as most of you probably know, the ME department in Mines is really focused on project-based learning. So a lot of hands-on, a lot of project-based learning, which means in the classes, we assign team design projects to our students, and that motivates the learning of all the theory that they need to learn in order to do that project, as well as all the engineering and implementation and prototyping and manufacturing involved with design, build, prototype, test, and demonstrate. So our zoo is our big open space, as you can see in these couple of pictures. We've got these butcher top tables and stools. And so students can come in with their projects, whatever they're working on, just plop it on top of a butcher top and get to work on their projects, doing assembly and piecing and maybe even some testing and things like that, right? So here's some other examples of the zoo in action with classes and other meetings. So we've got students, an alum visiting on the left side there. On the right side, you've got Dr. Bierenkot, where she's teaching our Intro to Mechanical Engineering course. And the students are all learning about buoyancy and static fluid dynamics, and so they're testing additive manufactured boats in the water there. Okay. Here's another application of the zoo. It's a very flexible space, so you can see that the butcher tops are all on wheels. The stools that we have in there are very lightweight and easy to move around. And so this is a photograph of our VexU robotics student organization practicing with the robot there, which has to go around and pick up those red and blue donuts and deposit them on those green posts, right? And so it's, they set up the arena, they use it, do their work, and then they put it down, right? So it's a very flexible, dynamic space. So that's where the zoo name come from, because like when you're walking around a zoo and you're visiting a zoo, you never know which animal you're going to see when you turn the corner. Well, when you come into the zoo, you never know which student teams, class, or project you're going to see. You're always surprised with something new and different. It's a very dynamic space. All right. And of course, it has some technology stuff in there. So like if you're working on projects and all of a sudden the professor, in this case, Dr. Thalakotor, needs to take something and share with the entire class, you can wheel in a whiteboard and we've got a big screen up there and stuff like that. So very dynamic, flexible space. Again, that central portion of the second floor, if you remember from your time here at School of Mines, right? Just adjacent to the zoo, we have another space called the aquarium. And the aquarium is where we have our additive manufacturing facilities in this shop. So you see in this photograph a bunch of additive manufacturing 3D printers. You see some more butcher top and stools, and that's for cleaning the parts, right? Because when you 3D print parts with additive manufacturing, with fused deposition modeling, you need to clean the parts afterward, get them off the build plate, things like that. So all that happens with hand tools using the butcher top in the aquarium. The aquarium, and like some other spaces in the Stensaas Labs, is staffed and run by students. We have student manufacturing mentors that through the generosity of some very um, successful and accomplished alums, they help us with the resources so that we can hire some students to work in these facilities. And these are students that have a lot of experience and knowledge in additive manufacturing. So they help their colleagues, the rest of their students in the ME department, they help them select which printers or white run to use for this, what material do you want to use, and then they have to set all the parameters when you 3D print, right? What's the fill? What's the wall thickness, right? How do you slice your CAD model and get it ready for 3D printing, right? With slicing software. So all that happens in the aquarium, right? And so here's students working in the aquarium. You see students on the right watching their print being happening, and you see Mitch, recent graduate, on the left there, and who's also one of our aquarium mentors and actually one of the leaders of the mentors that work in the aquarium. We also have this faculty meeting with students and visitors. So this is actually one of our faculty, Peter McCune, meeting with prospective students and their family as they're touring the ME department in the aquarium. And here's a close-up of a couple of the different machines we have in the aquarium. We have lots and lots of different additive manufacturing machines because it's, as you probably know, it's a very dynamic technology. The capabilities and new machines are coming out all the time. And so we have a wide variety of 3D printers and materials that we use in the aquarium. Another facility that we have in the Stensaas Labs is called the Cave. So one of our students named it the Cave because it doesn't have any windows. There's no natural light coming in. But that's a good thing for a computer lab, right? So this is the computer lab that we have to support our students. The school, if you're familiar with it, still has the laptop program. The laptop program is great. But when we're teaching students new software tools and concepts, we'll meet in the Cave. And then when classes aren't meeting in the Cave, it's available for students to use 24/7. And these are very, very powerful machines with really high-end GPUs. So they can do very, very complex dynamic simulations and modeling and CFD computations and FEA computations in the Cave. Right. So here are some students working with their models in the Cave. Another facility that we have in the Stensaas Labs, and this is our newest one, is we call it the Den. This was just completed about 1.5 years ago. And it's, as you can see, it's a modular space set up with these teaming tables. So this is where the facility that we have now to support our project-based learning, where the students are working in teams all the time. So this classroom, so we use it as a classroom. Professor will be in there with the students, and the students will be sitting at these pods with their teams, right? And then we also have it open the rest of the time for students to use, right? And so it's turned out to be a very, very popular resource. And I put this right after the Cave on purpose, right? Because the Den is our room and our facility with by far the most natural light, right? We've got these big windows, and even on the interior wall, we put a bunch of windows. So it's a very bright light space to support the creativity and the innovation that happens and the brainstorming and the ideation. All that happens here in the Den, right? And so here's a picture of actually students being engaged and working on their teams, right? In this very dynamic environment, the Den. Just down the hall, in between like the zoo and camp, is the forest. And the forest, as you can see in the picture here, this is our woods lab, our wood shop, right? We still do a lot of manufacturing and prototyping in woods or wood-like materials. You can imagine our student teams do a lot of fiberglass layup. They do a lot of carbon fiber layups. And for those, you need molds and patterns. And those are usually made in the forest using either wood, machinable foam, or machinable wax, right? And you can see we've got the usual woodworking tools in there, a lathe, and of course the most dangerous tool of all, the table saw. But if you look down there on the table saw, you see the saw stop. We do have a saw brake on there. So we try and keep everybody with all their fingers. Um, and if you see the snakes running around, we have a phenomenal dust collection system that really allows multiple people to be working with multiple machines simultaneously in the forest in a safe environment. So here's another view of some of the equipment in the forest. Uh-huh. And those butcher tops that you've been seeing in the aquarium and the zoo, yes, we made them in the forest. So here's one of the butcher tops. So we made those our own. Okay. Now I'll talk a little bit about the machine shop, which is right next to the zoo on the second floor. The machine shop, traditional subtractive manufacturing facility. Here you see our Haas CNC lathe, and then other lathes behind it. So this is a picture of what the machine shop looked like before the summer of 2025. And then during the summer of 2025, we had to affect some major repairs to our machine shop. So I put in these pictures here for fun, just to show you what we had to do last summer. We had to take all the machine tools, everything out of the machine shop, and you can see in the summer, we put them into the zoo. And we had to do that because we had to 100% empty the machine shop to effect repairs to the concrete slab. The slab was failing. 70 plus years of machine tools in there. And of course, what are machine tools? They're massive. They have a lot of mass. They're heavy. And they have rotary machinery. They have electric motors running. So they generate high frequency vibrations. And eventually, the floor started failing. And then, the building is heated by steam. So we're getting multiple steam pipe leaks. And so we had to rip up the floor, right? So here's the emptied machine shop, right? So this is a rare photo because this all happened in the summer. Our students, when I show this to our current students, they're all like, "What?" They can't believe this actually happened last summer. But yes, the machine shop was completely emptied, and then the floor was completely ripped up and replaced. So the jackhammers were here inside the machine shop, tearing up that slab, and you can see it's not a 3-inch slab. It was an 8-inch slab, but it still failed. So massive work that was done last summer, and now we're back to work in the machine shop. Totally rebuilt. We've got a floor that's going to last for a long time. And of course, we took the opportunity to clean, refurbish, paint after before we move back in. So lots and lots of upgrades happening in the machine shop last summer as well into last fall. We put in the last bells and whistles that we added to the machine shop. So these are all current pictures from fall semester or early part during the winter break here, showing the work going on right in the machine shop, which also includes a welding bay where we have arc welding, and we also can do MIG and TIG as well in there. Okay. Another facility in the Stensaas Labs that we have is called the Reef. And the students named this one, why is it the Reef? Well, it's right next door and adjacent to the aquarium. So they wanted to keep the aquatic theme, right? And it's got a lot of nooks and crannies along the wall where all the parts and supplies are stored. So they called it the Reef. And this supports our embedded software, mechatronics, controls activities, and all the projects our students do, right? So again, more butcher tops in here. There are electric cord reels above all the butcher tops so that they have power on their tables, not only for their student laptop, but for the electric equipment they're going to use, like maybe a digital oscilloscope or a function generator or a power supply, right? So here are students working in the Reef. And you can see in the back there, you can see all the different parts and supplies that we make available to the students to support their projects in the Reef. So all those racks on the shelves back there, they're hosting transducers, switches, breadboards, um, um, hats and shields for Raspberry Pis and Arduino microcontrollers. And then off to the side where you can't see, it's all the scopes and the function generators, the power supplies, the multimeters, soldering station, and all that stuff. Okay. Very, very busy and active space because a lot of the projects our students do involve controls, feedback, and so they become mechatronics projects. And then to support, again, all this project-based learning, this is the absolute most recent addition to the Stensaas Labs on the second floor, is we now have bright, shiny, brand new stainless steel project storage cabinets for all of our students. Up until now, students will be working on all their projects, and they literally had to take their projects back to their dorm room or to their off-campus apartment because there was nowhere for them to store all their projects on campus. The hardware, the prototypes, the parts that they've ordered, right? So now we have two big banks of these project storage cabinets. So the students, they come to the ME office. We assign them a locker. It's a combination lock, and it's very, very convenient for them. And they can get access to their parts and supplies, their materials, their prototype 24/7 right now, and keep it on campus right next to all the other facilities in the Stensaas Labs, right? And again, this was made possible by a terrific donation by an ME alum, and we're very, very grateful for this addition to the Stensaas Labs. Okay. So those are the pictures and the stories I wanted to tell about the Stensaas Labs, and I hope it was informative, and I look forward to whatever questions that folks might have. So happy to chat and answer your questions now.
Well, so far, I don't see anyone has added a question right into our chat section. So I'm going to talk for just a minute, give you a chance out there to hop on because I see a lot of MEs there. But I got to say, how many of you out there wish you could go back to school now? Because it looks a lot more fun over there, right? There's some amazing things. I love seeing this because selfishly, my kid is there. So I have a sophomore, a mechanical engineering student with Dr. La Rochelle. So I love seeing all the support and all the great things he gets to do with that. All right, we do have a question here. What CAD or CAM software are you using?
Okay. Okay. We have a bunch, right? We pretty much have all the major CAD and CAM software. The one that we teach our students is SolidWorks in terms of CAD and Mastercam in terms of CAM. But like in our design courses, if a student comes in and they already know PTC Creo or CATIA, right? Or any of the other, or AutoCAD or Autodesk or Inventor, right? Any of those, we're pretty much agnostic. We really don't care, right? It's all solid modeling, right? So the CAM gets a little bit more complicated because it has to actually interface with our hardware, right? It's got to produce G code that will run in our machine shop, for example, or run the 3D printers in the aquarium. I didn't mention, but in the forest, in the picture there was a CNC router table, which also, of course, runs on G code. So, we have to use CAM software that has drivers that interface and generates G code that works on our hardware, right? And of course, there's CAM built into SolidWorks, and we have the full-blown SolidWorks license. So the two CAM softwares that we have are the SolidWorks CAM option and then Mastercam.
Excellent. All right, I'm going to go with Jerry's and then I'll go to some that are in the chat. All the way from DC area, Jerry asks, what kind of joint programs do you have with industry?
Oh, okay. Almost everything I talked about, all these facilities in the Stensaas Lab, they all involve industry partnerships, right? That's how we get the equipment, or we had help to get the equipment, or the software, or the supplies, or the materials, right? And then this tremendous feedback that happens with our industry partners through our department's external advisory board, which involves the voice of industry, right? Industry reps from all the major industries that hire our students. Today's Thursday. Tuesday was our career fair, right? The recruiters come to campus. A ridiculously large number of recruiters come to the School of Mines. It's amazing, right? And of course, there's a good chunk of them that are alums. And whether they're alum or not, they come and they visit the departments before or after they meet with all the students. And so yesterday, the day after the career fair, was a steady stream of industry partners coming to the department office, saying hello, introducing themselves, and then I give them a tour, show them around, because they want to see how we're producing the students that they met on Tuesday, because they're so impressed with our students that they actually know the theory of engineering, but they know how engineers actually put it into practice to design, build, prototype, and test a real working product. So all that feedback comes in all the time to help us stay on the cutting edge of ME education.
Absolutely. Oh, great. Marlene asks, can you talk about the impact of the Stensaas endowment funds?
Yes, yes, yes. So underpinning everything I showed today is none of that would have happened without the Stensaas and Laboratory Endowment and all the gifts that people have made to the Stensaas Laboratory Fund, right? Those resources have been phenomenal to help us. Almost every space that you just saw that I share with you in the Stensaas Labs, almost every one of those is new within the last 5 years, right? And all that happened as a result of the Stensaas Lab campaign, right? Those resources enabled us to do the remodeling, to get the additional equipment, to renovate these spaces, to expand the spaces, to do all of that. So without those resources, we would unfortunately just be another school teaching a lot of theory and a lot of simulation and not the hands-on project-based stuff that we do. It's a difference maker.
It really is. I hear from students that come back from internships and they're like, yeah, I was at this internship. I was only supposed to do this little bit, but once they saw what I knew, they got much larger projects to work on because they come in with that hands-on where their fellow interns are behind the game. So it really does make a difference. All
Yeah.
right, Angela has asked, do you have a master's program in manufacturing or mechanical engineering or
We have a
combo?
master's program in mechanical engineering and a PhD program in mechanical engineering. Those are our two current graduate programs in the department. Um, the mechanical engineering, we do have faculty that specialize and focus in manufacturing. So if that's your interest and your focus, you can get a master's or a PhD in mechanical engineering with a focus in manufacturing. But the degree will say mechanical engineering.
And we have some, I know you spoke about it before, but just to reiterate on this Zoom, we have specializations that students can go after too. Can you speak about that real quick?
Sure. So at the undergraduate level, our students have multiple areas they can specialize in. The first one being dynamic systems, controls, and robotics, right? The next one being solid mechanics, right? And then thermal fluid systems, right? And then design and manufacturing. So those are the four areas that our undergraduates can specialize in. We have undergraduates that they're hook, line, and sinker into one of those, and they take all their electives and they take extra courses in that. And then we have other students that want to have a breadth of maybe a couple of them. They don't want to just specialize in one, but maybe in a couple. And then we have some other students that they're more like they're like at a buffet. They want a little bit of this, a little bit of that. They want to get it all and be like a Renaissance engineer, right?
Absolutely. Thank you. John asks, what are some of the corporate sponsors for the lab equipment and support, and what are your next improvements that you're seeking?
Yeah. So our corporate partners for the lab improvements. So I'll go back in time, right? So a big partner that we have that helps us every year is Nucor. Nucor provides resources to help us hire those students to work in the Stensaas labs. We have 675 mechanical engineering undergraduate students. We have two full-time staff in the labs, right? They can't do it all, right? And so what happens is we have these great undergraduate students A lot of them, they grew up on a farm or a ranch. They've been working in a machine shop that they had on the farm or the ranch for 10 years. They come to us, they have all these skills. And so we hire them and they help us with our training of other students, monitoring students, and advising and guiding students so that, of course, they use our shops and facilities in a safe manner and have all of these when they graduate, right? And a couple of these and all that stuff, right? So UCORs have been a great partner to help us with hire these students. Haas, Kiewit have been great partners to help us in the labs. Yaskawa Motoman, which is a robotics company, has been very instrumental in supplying us, help us acquire some of the latest, greatest robotics technologies, right? MakerBot in the aquarium has been a good partner with us as well. Okay, so those are some of the good partners.
Excellent. All right. Don has more of a comment than a question, but he says the facilities look great. I agree. Back in 1954 to 1958, when he was there on campus, his dad's home shop was better equipped than that was available for our students on campus. So, um,
Yeah,
yeah.
that's not the case now.
So Don, come on back. We'll let you
Yeah,
get your fingers dirty. Keeping them all, but we'll let you
yeah,
get your
yeah,
hands on the equipment.
yeah,
So
yeah.
excellent. Let's see. Before we end, I want to give a chance for anyone else to have a question. Make sure I didn't miss anybody. Looks like I have them. One point I would like to say that if, when you do come back to campus, let us know. If you let us know before you're coming, we'll block off our day. We want to see you. We want to show you what we're doing and some of the amazing things in person. So both Dr. Levershell and we're here. We want to meet you. We want to hear your stories. So, well, thank you very much for presenting in this census and all the work because not only is he got the most students, he's got some of the biggest staff, and he's a very busy man. So I appreciate your time and sharing with us in the alumni community today. Alums, I hope to see you at one of our future events. I see a lot of familiar faces I saw on campus. I know some of you have recently been back to campus, and I hope if I don't see you in person, I hope to see you on the platform of Hard Rocker Connections and connect with you there. So thank you very much. I hope you all have a great Valentine's weekend next weekend and go Patriots. Thanks, guys. Bye bye.
Bye.